Hello, my name is Alina, and today me and my colleague Mikola are gonna present you a topic called automated identification of medical documents and images. So first, we're gonna talk about why is it important and what exactly should we protect. And after that, I'm gonna share with you some new methods and the new technologies used to process text data. After that, I will hand over to my colleague Mikola, who's going to talk to you about OCR and how we can process raw data through the OCR and after create the identified copies of that. So, okay, let's start. First, why is it important? Why do we speak about the identification at all? So there is a common case by Dr. Switney, who worked in Cambridge and performed a case of de-identifying the facial document based on open sources. And then in the end, she sent the results to the governor of Massachusetts with his private records. Well, it's not really acceptable, and no one wants to have their medical records openly exposed to the internet. And currently, a lot of companies trying to protect and comply with the law to identify the potential breach sources and the ways to protect patients' data in the medical domain. So that attack was performed in 1997, but the topic is still actual. This is a data from 2019, and we see how many breaches happened in the world and how many patient data got exposed publicly. When the companies who been under attack after have to perform a bankruptcy or have to face a heavy court case to for the patients. So it's always should be a balance between personalized treatment and privacy of patients. And we see how it's going with traditional medicine and precision medicine when we try to treat the disease or we do the customized treatment of a patient. So what exactly is the protected information? There is a few compliances we have. One is in US, which is called HIPAA compliance, which include a lot of different data sources and the procedures to protect private data. What we mostly concerned here is encryption and authentication. So it's technical protection information of data stored in a database. The examples from the HIPAA compliance can be birth dates, social security numbers, death certificates, names, of course, medical records, and some other information what can directly lead to the patient and to show his identity based on the records which was stored or publicly exposed. Why is it, so how do we measure that? We first need to identify where exactly the information is located. If it's going to be used publicly in the open data set or if it's going to be used internally within a company. So based on that, we identify how much protection we need and how much we should cover the data. Should we tag that? Should they identify it? How secure it should be stored? And what procedures should be applied? So when we start working with the data, we first identify maximum risk thresholds. And based on that thresholds, what we found, we try to understand the procedures we implement. So there's another thing we should consider is a probability of re-identification of the patients. When we do that, we check our data sets and we see what kind of groups we can see in our data sets. And then within this equivalence class size, which a group we found, we defined the K-anonymity metrics, which show us the probability of the identification of a smallest group of the patients we have. What documents we work with? The common formats for the documents is a text data, Dicom objects, and PDF. This formats is used in the medical domain to exchange the data and to transfer data from one healthcare provider to another. In my part, I'm mostly focusing on the text data, and my colleague will cover the Dicom objects and the way we worked with that. What's the common examples of medical documents? And most of the cases is medical history records complied by doctors, but it also can be insurance record, test result, examination, and many other reports. Currently in the world, the medical documents and medical data are growing, and the personalized treatment like required to be analyzed specifically, and to be able to run some models or to pass the models to the third case providers, we need to make sure the data are secured and we're not exposing any private data. So how do we do it? How do we identify it? There's a few approaches we can use. The most simple one which comes into our mind is rule-based approach, when we try to see what names we commonly use, what hospitals we have in our data set, and we just change these names on some regular expressions. When there is more complex, a model-based approach, when we train some NLP model to identify entities, and then we extract it from the information. But as we see from our practice, the most reliable is hybrid approach, when we join the rules we have and the model we train to make sure all data was secured and extracted from initial documents. So here is I can show you how we work with that in the Spark NLP. As you already could see, the Spark NLP using a pipeline of annotations in their procedures. And in this pipeline, we have different steps to pre-process the document and until we come to the final step, which is going to be name entity recognition and the identification. So here is the common steps when we start working with documents. It's document assembler and then sentence detector, tokenizer, where we split the sentences to the words, normalizer if we need it, and then we use different word embeddings. It can be pre-trained embeddings for clinical data, which specialized in the domain, or can be general word embeddings like a glove or bird, or it also can be a custom embeddings if text is very specific and require a personalized embedding training. In our process of the identification, we first have to find the name entity recognition model which suits us, or to train our own name entity recognition models. What exactly extracted by that during that process? So the entities are extracted, it's from HIPAA requirements, and its name, profession, age, date, contact number, location, everything what can identify the location, and different types of ID, which can be ID from documents, personal documents, security numbers, insurance, and so on. So, and the next step is going to be the identifier. There is a few ways to work with that. We can remove the tokens, which will create not very readable text. And in this case, we lose a lot of information. So in the process of the identification, we have a few metrics where we can measure the information loss. It's entropy of the text and its missingness of the text. So basically in the first approach of removal, we miss a lot of information. We don't even know what type of token was there. So the second one is a tagging, where we tag information with related NER token, which is person in my example, or location. And the last mode is obfuscation, where we replace found tokens with randomly selected tokens from a list, which makes text readable, but at the same time, they identified. So here's the coding part and a short example that I'm going to show you how we do it with Spark NLP. So first we create a session where we include OCR, NLP library, and public Spark NLP. And then we create a pipeline, one I already mentioned, which includes document assembler, sentence detector, tokenizer. When selected NER model, it can be a NER DL from clinical data or some other. Then we use NER converter, and in the very end, the identification model. So first, let's prepare tokens. We will have document assemblers, sentence detector, and tokenizer as the first part. Here's an example of how we can use that. And then we load embeddings. So in pre-trained models, we use word embedding trained in public med dataset, which is called embedding clinical. It's specialized for medical domain, and it was labeled based on the specific of medical texts. And after we use the model we have is the identification model from also clinical domain. And the next step is going to be the detection of the tokens. So there are some special cases what can be covered. Sometimes we see that some names can be missing by a model. So in my example, we see that the name of patient was missing and it was not identified. So in this case, we can apply the rule-based system, what I mentioned before. And in this rule-based system, we will have overwriter, which will add the desired entity into the chunk. And then we also can exclude some entities based on the task we have. So in this example, I exclude location. So then the last step is the identification model, which can work in two modes, masking or obfuscation mode. Here's an example you see. So we have a list of replaced entities for the model in the obfuscation mode, and some entities are always tagged. Also, there's an ability to train custom model, and here is how it goes. You can check the code later. I've shared all the examples in the links in the end of the presentation. So, and now I'm going to hand over to my colleague, and he's going to continue about medical documents and the way we read it.
Hello, I'm Mikola Melnik, and I'm leading developing Spark OCR in Johnson Labs, and today we'll talk about using Spark OCR for identification PDF, Dicom documents, and images. Alina already provided some solution for identify text documents and for deal with more complex formats such as PDF, Dicom, image. We need for start extract text data, and Spark OCR provide various of transformers for do this. Spark OCR based on Spark email, and it provides functionality for text recognition, PDF processing, image processing, layout analysis, and some utility transformers for identification. And for deal with images in Spark, we need to store images in data frame. So we have some specific image struct for this, and which contain all needed fields for storing images. And we have three main groups of transformers for identification. This one for reading data, this one for processing text, and last one for storing back to the original format. So we have PDF to image, PDF to text, Dicom to image, and image to text for recognized text. This positions finder and update positions. This is utility transformers for identification, and text to PDF and image to Dicom for storing back. This is example of Spark OCR pipeline for identification PDF document. So we should read PDF document using PDF to image, and after that we can have some pre-processing for cleaning image, recognize text, using image to text, deidentify, document using Spark NLP, and store back to the PDF. For identify images, we have a bit simpler diagram. So we can recognize text using image to text, and after that call Spark NLP transformers and draw regions for hide text sensitive data on the image and store back it to the original format. For identifying Dicom documents, we have Dicom to image and transformer, and also we using image draw regions transformers for hiding sensitive data and store back to Dicom format. Let's look more in detail to the Spark OCR transformers, and main of this is image to text transformer for text recognition from images. So it have various parameters for configures text recognition, and we should specify input column with input image and output column for storing recognized text. Another one useful transformer for identification is positions finder. So when we extract entities using Spark NLP, we should found coordinates of text, and positions finder can help with it. So we should specify input column with entities and output and input column with original positions. And output will be in coordinates of regions with needed entities. Another one, transformer update text positions needed for implement obfuscation for with keeping formatting. This transformer is used for obfuscation of PDF documents. And for the identification of images, we can use image draw regions transformer for hide sensitive text. So we can specify text, or we can specify color of rectangle, which will use it. And let's look to more examples. For reading image, PDF, and Dicom documents, we are using binary file data source of Spark. And after that, we will able to re-edit using PDF to image or PDF to text transformers. PDF to image we need to use for scanning documents, and PDF to text for selectable PDFs, which already digitized or which was originally in text format. And for image scanning documents, we need to call image to text transformer for recognized text. After that, we can apply identification pipeline based on Spark NLP. Alina more detailed talked about it. And for storing results back to PDF, we should call update positions transformer and text to PDF for storing back. So see we can see here some example, and we replace it original name and replace date by tech. For Dicom documents, we also should read files using binary data source, and after that extract images and metadata using Dicom to image. So we can see example of metadata in JSON format and images from Dicom files, which contain text on image. And for the identification Dicom document, we have a bit more complex pipeline, which included identification of metadata and image. So we have here two calls of identification NLP pipeline. And for hiding sensitive info on image, we are driving rectangles using image draw regions transformer, and store back metadata and images to Dicom format using image to Dicom transformer. So this is the result of the identification of Dicom documents. So we can see here black rectangle, and here which are hiding sensitive data. You can find examples and of notebooks and documentation of Spark OCR here. And please, you can look Spark OCR workshop with a lot of examples of using Spark OCR and examples of full pipelines of identification, different type of documents. Thank you.